Hello all. Today we are going to solve the longest common subsequence problem using dynamic programming approach. Dynamic programming. So before going through the problem statement, let us try to understand what do we mean by the subsequence. Okay, so assume uh, that x be a sequence having x1, x2, x3 up to xn as its elements. Fine. Then then we will say that z that is equal to z1, z2 up to zk will be the subsequence of x if there exists an increasing order sequence of indices of x such that और ये indices increasing order sequence of indices ये let these indices are equal to I of 1, then I of 2, then I of 3 and I of k. Let these is the increasing order of indices. Fine. So of x, it says that z which is equal to z1 up to zk will be called as subsequence of x if there exists an increasing order sequence of indices of x such that x of I of 1 is equal to z of 1, x of I of 2 is equal to z of 2, and x of I of k is equal to z of k. Fine. So let us try to understand it through an example. So suppose x was given to be equal to a string which is equal to computer. Fine. So we can have a subsequence z which is subsequence number z1 which is equal to cmptr. Fine. And the indices for this sequence are equal to c means 1, 3, then 4, then 6 and then 8. So these are the indices, or we can say that x of 1 is equal to z of 1. Yes, no, x of 1 was c, z of 1 was c, done. And in the same way x of 3 is equal to z of 2, this one. Fine. X of 4 is equal to z of 3, this one. And x of 6 is equal to z of 4, x of 6 is equal to z of 4, and x of 8 is equal to z of 5, which is this r. So this is what do we mean by the term subsequence. So in this case CMPTR will be called as a subsequence of x. In the same way Z2 which is equal to COM is also a subsequence of x with the indices equal to 1, 2 and 3. And in the same way COTER is also a subsequence, CTER is also a subsequence, CMPTER is also a subsequence. So these are all subsequences for this string x, for the sequence x. Fine. The only thing to remember here is that indices should be in the increasing order. Fine. Or you can say the order or the sequence of appearing the characters should be maintained while generating the subsequence. There is one another way to look at the definition of the subsequence. So let us discuss that also. So let computer be the word or the sequence whose subsequences were to be generated. Then we can say that all the strings which can be attained, which can be achieved by deleting some of the characters, some of the elements of the sequence are called as, let's say, sequences. So in example we can see, let us delete these three characters. The remaining are C, M, U and E is a subsequence. Fine. In the same way, let us try to delete this C, this M and this T. इन तीनों को डिलीट कर दो, मार्क्ड एज ग्रीन. तो जो रिमेनिंग वन है वो क्या है, सबसिक्वेंसेस है. वो कौन से है, O, then P, then U and then E. Fine. So these are also the subsequences for the word computer. So you may follow any of these definitions. The first one is a bit technical, and that is I think you must concentrate upon the first definition. The second one is the name one. Okay, so both are correct. Now after understanding what is the meaning of the term subsequence, now let us suppose there were two sequences given. One was X and one was Y. Fine. And Z1, Z2, Z3 and Zk. Suppose these are all subsequences of X, and there are in the same way some of the subsequences of Y also. Fine. So the subsequences which are common to X as well as Y, or you can say the subsequences which are common to X and Y are termed as our common subsequences. These are common subsequences. And out of these common subsequences, our target is to find the subsequence which is the longest in length. So we need to find the longest common subsequence. Fine. So it means two strings for their X and Y. First we need to generate subsequences for X, subsequences of Y. Then we need to find the common subsequences between X and Y. And now out of those common subsequences we need to find the one having the longest distance, which will be termed as longest common subsequence of X and Y. So this is the statement of your problem. We are provided with two sequences. One is X and one is Y. We need to find the length of the longest common subsequence, as well as we need to print the longest common subsequence also. Longest common subsequence भी print करनी है और उसकी length भी print करनी है. So this is our goal of today's lecture. The problem of finding LCS or longest common subsequences can be seen as the problem of finding prefixes of X and Y. Okay, so in other words, we may say that problem of finding the LCS of two strings X and Y can be seen as the problem of finding the lengths of prefixes of X and Y. Now what exactly we mean by the prefixes? So let us suppose our string X was equal to A, B, C, D. Done. Then we can say that this X is having X1, means to say X1 which is equal to A as its prefix. X2 will be equal to AB, which is also a prefix of X, x3 is equal to a, b and c, and in the same way x4 is equal to a, b, c and d. In the same way x0 is equal to a null string. So these all are the prefixes for your string a, b, c, d, or you can say that xi prefix denotes the string starting from index 1 to index I. Fine. So x2 means starting from 1 ending at 2. Done. So these are all the prefixes of x. In the same way we can generate the prefixes of y also. Fine. It means if you are having y is equal to x, y, z, not exactly this. Let us suppose y was equal to uh, b, c, f, g, h and I. Then y3 will be equal to bc and f, y of 2 will be equal to bc, y of 4 will be equal to bc, f and g. So I hope prefix notation is clear to you. Fine. Now move to the problem in hand, that is to compute the LCS of x and y. So assume that we are having x equal to a word that is compute. Fine. And we are having y which is equal to the word option. Now we need to generate the LCS of the longest common subsequence for this. Fine. So the length of this x is equal to 7, the length of this y is equal to 6, or you may say that x can be written as x7 and y can be written as y6. So what exactly we need to find is the LCS of x7 and y6. Fine. So we need to compute this LCS of x7 and x6. Now what exactly he says is that LCS of x7 and y6 can be written as per this equation. Now for writing this equation we need to understand what exactly is going to happen. So there are two words, one is compute and one is option. So for generating longest common subsequence, start from the last letter. Start from the last letter of each word. That is this one, E from X and N from Y. Fine. Start from this word. What it says is that the length of the LCS here will be equal to, it will be equal to 1 plus length of x6 and y5 if x6 was equal to x7 was equal to y6. If x7 was equal to y6, x और y दोनों के small x and small y, what exactly they are the values of the element. So what exactly it says is that if these two letters are same, then we are sure that one letter is matched, or there is a match upon the last letter of both the sequences. It means the sequence is going to be increased by 1. Okay, fine. So this one is for that match, and the rest of the length will be equal to the LCS of this one. कि हमने क्या किया, इसको 1 से डिक्रीज कर दिया लेंथ को. We decrease the length of x by 1 and also the length of y also by 1. Now the length of this LCS will be calculated. Fine. This is the case when this last letter was equal in both the strings. Fine. So this is the equation for this. It means LCS of x7 and y6 will be equal to 1 plus LCS of their prefixes with one decreased length. Fine. Now the second one is that suppose they are not equal. If x7 is not equal to y6, कहता है these two are not equal because e is not equal to n in this case. Fine. So there will be two options. Option number one is that go for computation of the LCS for x of 6, x of 7 and y of 5. OPTIO कहता है एक बार तो क्या वन for one time just leave the last letter from string y and for the other time leave the last letter from the x. So PUT and OPTION. Fine. So कहता है we need to find the LCS of these two prefixes. Okay, and one out of these, which is the maximum, is going to be chosen. Fine. The thing is very simple. This is what we follow when we do it by paper and pencil. Fine. If there were two strings, we just match the last letter. If this is same, then we need to add 1 to the LCS of this part. Decrease this string by 1, decrease this string by 1. And in the other case, if this was the last letter from x, this was the last letter from y, they were not matching. Done. Then we need to consider this as a complete sequence, and this is the decreased sequence. Fine. In the same way, in the second case, we need to consider this as complete and this as the decreased one. Done. Now we need to choose the one out of this and this which is having maximum LCS. Fine. So the mathematical representation for this task can be written as that it will be equal to maximum of LCS of decrease x from x by 1 and keep the y same, and in the second one LCS of, now keep the x complete and decrease the y by 1. So this is going to be the maximum, and this is the case when x of 7 was not equal to a y of 6. Fine. And now the third case, if we try to write a generalized equation for this, then we can write that if we are considering the LCS of a string that is considered till I character, and the second one was considered till j characters. ठीक है, this is the prefix from x, this is the prefix from y. So the equation can be written as that it will be equal to 1 plus LCS of x of I minus 1 and y of j minus 1 if x of I was equal to y of j. Then it was equal to max of LCS of x of I minus 1 and y of j and LCS of x of I y of j minus 1 if x of I was not equal to y of j, and there is one another, that is equal to 0 if I was equal to 0 or j was equal to 0. Now what does it mean? What does it mean? Consider the case when we wish to find the LCS of x of 0 and y of 4. X of v0 means null and y of 4 means the first four characters. So the common between them is going to be a null string. So it will be having length equal to 0. Yes, no. And in the same case, if we wish to have LCS of x of 3 and y of 0, and again this is the null, this is the 3 character string, and the common subsequence is going to be having the length equal to 0. So this third case is for the case when I was equal to 0, j was equal to 0. So this is the generalized equation for generating the LCS. Okay, now suppose we are having an entry that is C of ij, which represents the length of longest common subsequence when x of I and y of j were considered. और यू कैन से ये जो सी आई जे ए क्या उसकी लेंथ दे रही है, लेंथ ऑफ द लॉन्गेस्ट कॉमन सबसीक्वेंस दे रही है, ये वाली फाइन लेंथ ऑफ द लॉन्गेस्ट कॉमन सबसीक्वेंस दे रही है. तो वी कैन जस्ट मॉडिफाई द इक्वेशन रिटर्न अबाउ. सो द न्यू इक्वेशन will be equal to C of I and j. It denotes the length of the longest common subsequence when x of I and I prefix and y of j, a prefix of y, were considered. So it is going to be equal to 1 plus C of I minus 1 and j minus 1 if x of I was equal to y of j. It was equal to maximum of C of I minus 1 j and C of I j minus 1 if x of I was not equal to y of j, and it was equal to 0 if I was equal to 0 or j was equal to 0. Fine. So this is the final equation or the final computation or recursive definition of our solution. Okay. Now let us try to see how this fits to our solution. How this fits to the dynamic programming based solution. So we were having two words, two sequences. One is x that was equal to compute, and y was equal to option. Done. So it was x7, it was equal to x6. Fine. So the LCS of them will be stored in 7 and 6. We can say 7 and 6 means when x7 was considered and y6 was considered. ये क्या है? Prefix. These are all prefixes. x7 is a prefix containing the complete string x. y6 is again a prefix containing the complete y. So we need to generate this. Now for generating C of 1 of 6, we'll be requiring three. The problem for three sub-problems is the solution for three sub-problems. The first one is will be requiring the C of 6 and 5. Fine. Second one will be requiring the solution for C of 6 and 6. The third one is we will be requiring the solution of 7 and 5. Now from where these three terms came? These three terms came from the definition, this one. Just put 7 here and 6 here. The solution will be requiring these three parts. Fine. Now for solving these three, so this one will be solved by having C of 5 and 4, and by having C of 6 and 4, and by having C of 6 5 and 4. In the same way it will be solved using C of 5 and 5, C of 6 and 5, C of 5 and 6. In the same way it will be solved using 6 and 4, using 7 and 4, using C of 6 and 5. Fine. Now further this again will be bifurcated in three parts, divided into three parts. Till when? Till we reach at the bottom level, and the bottom level will be containing C of 0 1, C of 1 0, and C of 1 1. So this is going to be the bottom level for all of these. These all are going to end here. Fine. Now we already know that C of 0 1 is equal to 0, C of 1 0 is also equal to 0, and C of 1 1 will be equal to C of 1 1 will be equal to 1 if x of 1 was equal to y of 1 and was equal to 0 if x of 1 was not equal to y of 1. So this value can be directly calculated. Okay, now once these values are defined, then this will be used to calculate all the entries at the next level, and further to the next level, further to the next level, and till this C76 is not achieved. So this is the overview of the solution using dynamic programming. Now try to observe that C of 6 4 is calculated here also. Fine. 6 5 calculated here, 5 4 calculated here, and calculated 5 4 here also. Yes, no, twice. It is wrong, I think. This is equal to 5 4, this is equal to this should be equal to 6 and 4. This should be equal to 6 and 4. So just leave this, just concentrate upon these two entries. कि ये वाली entries, this one is calculated twice, then this one is also calculated twice. If we just try to complete this tree, then there will be many terms which will be computed 4 times, 5 times, 10 times, 12 times, and many. So these terms were earlier used to be recalculated again and again when divide and conquer or your greedy approach was used. Now the benefit of the dynamic programming is that if we can have a table, okay, if we can have a table that stores the intermediate values. Okay, suppose here C of 0 0 was stored, C of 1 1 was stored, okay, then C of 1 2, C of 1 3 was stored. Fine. So for calculating the values at some later stage, these values from the table will be reused. So there will be no need to recalculate them again and again. This is the recursive solution that we just wrote. And now assume that there were two strings x and y for which we need to find the LCS. Okay, now for generating the LCS of x and y, we need to generate a table that is to be made as according to this definition. Fine. So let this be the table. So these there are as many number of columns as the number of characters in y. So they are equal to 6, and there were as many as rows which are there in your x. Fine. Now consider one more row for the zeroth value. Consider more column for the zeroth value also. So this is the extra column. This is the extra row for us. Fine. So row wise we are going to represent your first string, that is compute, and column wise we are going to represent your option y. Option 1. Fine. So concentrate upon this one. Now this denotes C of 0 0. Yes, no. There are values. This is value 0. Then this is suppose this is and this is first. This is 2. This is third, fourth, fifth, and sixth. And in the same way, this is 0. This is first, second, third, fourth, fifth, sixth, and 7 row number. So this value 0 0. It means we are going to find the LCS of x0 and y0. So by the definition or by the third line, this one it is going to be equal to 0, and by the application of the same line, or you can say same condition, this is going to be equal to 0. Fine. Now concentrate upon this column. In this column, the lengths of the x are going to be increased, but the length of y remains equal to 0. Fine. So this column is again going to be having values which are equal to 0 0. Fine. Just try to understand this value. This is the value number, that is at this stage we are trying to find LCS of x3 and y0, because this is 0, so this value, or you can say this will fall under this condition, and so 0. Just by following the same process, these all entries in the first column are going to be equal to 0, and in the first row are going to be equal to 0. Now move to this one. So this is your entry number LCS of 1 and 1, means when x1 and y1 were considered. Fine. So in case of x1 and y1, x1 was equal to C, y1 equal to O. So we need to make a comparison between, and while comparing, these two are unequal. So C was not equal to O. So it goes to the second condition. Fine. So for the second condition, it has to choose a value which is the maximum amongst LCS of 1 means I minus 1 and j means 0 and 1, and LCS of I and j minus 1, which is this one. So both these values containing zeros, 0 1 is equal to 0, 1 0 is equal to 0. So 0, those 0 out of 2 zeros, which is maximum? The 0. Now consider this one. So this is the entry which is equal to C1 of 2. It means here we are going to consider x1 and y2. x1 means C and y2 is equal to O and P. Now we need to find the length of the LCS for these two. Fine. Clearly no LCS. No LCS, na? No LCS, or you can say you can directly apply the condition that if x of 1 was equal to y of 2, or if C was equal to P, it was not equal to, it means again we are going to move to the next second condition. Second condition क्या कहते हैं? We need to choose amongst the maximum. Maximum कौन सा? LCS of 1 and 1 and LCS of 0 and 2. Fine. Now this value is equal to 0 and 1 1. Just try to have it from the table. 1 1 कितना है? Is equal to 0 है, तो ये is equal to 0 है. So 0 or 0 out of these two, which is the maximum? That is equal to 0. Okay. Now try to fill the third one. This one. This is the LCS of 1 and 3. LCS of 1 and 3. It means when x1 was considered and y3 was considered, so x1 is equal to c and y3 is equal to OP and T. So clearly it is equal to 0. Next, this one is again equal to 0. Then this one is again equal to 0 and this one is again equal to 0. Fine. Now move to this one. So this is the entry number C of 2 and 1. This is C of 2 and 1. It means we are going to consider x2 and y1. So x2 is equal to C and O and y1 is equal to O. Fine. Now we need to make a comparison whether x of I or x of 2 is equal to y of j or y of 1. So O is equal to O. It means first condition of this recursive definition will be followed. This one, when there is equality between x and e and y of j. Okay, so just follow this, and if we follow this, then we can say that because x2 was equal to y1, so this entry is going to contain 1 plus c of I minus 1 means c of 1 and j minus 1, it means 0, and this entry we already know is equal to 0, so this is going to be equal to 1. Just put 1 here. Fine. Now in the same way, try to generate this entry. It is going to be equal to 0, going to be equal to 0, going to be equal to 0. Now consider this one. So this is entry number C of 2 and which one? C of 2 and 5. C of 2 and 5 it is, to be very exact. 2 and 5. It means we are going to consider x2 and y5. x2 is equal to C or O and y5 is equal to OPTIO. Fine. So these are the two strings. Now try to find their LCS. For finding LCS, we need to compare x2 with y of 5, which is equal. Done. If it is equal, condition number 1 will be followed. 1 says that we need to add 1 in the LCS of I minus 1 means 1, j minus 1 means 4. Fine. So this is going to be its value, which is equal to 1 plus LCS of 1 and 4. LCS of 1 and 4 kitna? This is 1, this is 1, 2, 3 and 4, which is equal to 0. So this again is equal to 0, 1 plus 0 is going to be equal to 1. So it will be 1. Fine. And in the same way, try to generate this value also just by following the same process, same procedure. Try to fill all these entries. Fine. Once we reached to this entry, so this is the entry denoting C of 7 and 6, means it is the length of the subsequence when x7 and y6, or you can say when COMPUTE was considered against option as a whole. Fine. So it is going to generate the length of this common subsequence, which is going to be longest in nature. Fine. So whatever comes here is going to be the final answer. Let us try to write the algorithm for the solution of this problem. So we already know that this was the recursive solution that we wrote, and this was the final table that we generated. And the property or the beauty of this table is that this row is going to be used for generation of this one. This one is going to be used for generation of this one and this one and this one. And even within the row, some of the entries like this one will be generated by using some of the entries generated in the earlier row and some of the entries generated in the same row also. So just by pursuing this, we are going to reach to the entry which is equal to 7 and 6, C of 7 and 6. Or you can say if x was of length m and y was of length n, then the entry m and n is going to give you the final answer, that is the length of the longest common subsequence. Fine. So let us try to understand the algorithm. So the name of the algorithm is LCS length. Two sequences x and y are passed to it. So let the length of x be m, length of sequence y be n. Fine. Now let us b is equal to, that is of the order of m is to n, and c be the order of m plus 1 and n plus 1. There are two matrices. So this is the first matrix, this is the second matrix. Now for now just leave this b. Concentrate upon the generation of this c only, which is this one. Okay, so we'll understand b at a later stage. Fine. So the first thing that we need to do is that we need to initialize this row with the value equal to 0 and this column with values equal to 0. So this is the loop, or you can say this is the these are the statements responsible for making first row equal to 0. Fine. And this is these are the statements which are responsible for making this column as equal to 0. Fine. Now move to the next one. Now we need to generate the matrix for I is equal to 1 to m, for j is equal to 1 to n. Done. It means we need to generate the matrix from this. This is the part. This one. So this is the part which is going to be generated. Fine. This is the part which is yet to be generated. This one. So this is varies from 1 to m. Yes, no. This varies from 1 to m and 1 to n. Fine. So we need to run two loops. One is y is equal to 1 to m, for j is equal to 1 to n. Because this marked matrix is of the order of m is to n. Means m number of rows are there and number of columns are there. Fine. So now we are just going to fill the entries of c of I and j, where I varies from 1 to m and j varies from 1 to n. Fine. So initially first row will be filled. It means c of 1 1, c of 1 2 and c of 1 and n is going to be filled. Done. Now the formula to fill these all entries will be this. This equation will be followed for generating each and every entry. Fine. Just pick the c of 1 1. Now apply the condition. If xi was equal to yi, then we need to follow the second step, this one. Now this second step, if xi was equal to yj, then we need to follow the first step, this one. It means if xi is equal to yj, follow the first step of the recursive definition and put or you can say just update c of ij to this value. Fine. Just leave this for now. Now consider the second case when xi was not equal to yj. In that case we need to compare two values. One is c of I minus 1j and the other one is c of ij minus 1. These two are going to be compared, and the one out of these which is maximum is going to be assigned to c of ij. So this is done using this statement. Else if means when xi was not equal to yj, then we need to compare these two. Fine. If this is true, then c of ij is going to contain this value. If this is false, then c of ij is going to contain the second value. Fine. So in this way, this matrix is going to be generated. Fine. And the final entry, which is equal to c of m is to n, is going to be generated. Done. Which represents the LCS of x and y. It is giving the length, to be very exact. It is generating only the length for this. Now after generating the length of the longest common subsequence, till now we have generated its length, but along with length we also need the elements. We need the elements forming the longest common subsequence. Okay, now for generating or for printing the elements which constituted your longest common subsequence, we just need to go again to the basics. So let there be two strings x and y. So let this is our x, this is our y, and we are just at the very end. So we are just you can say making a comparison, or you can say we are finding the LCS of x of m and y of n. Done. So we are at this stage. We are comparing these two elements. We are making a comparison in between. So there will be three cases. First one will be when xi is equal to y of j. This small xi is equal to y of j. So in that case, we need to update the LCS by 1, and we are sure that xi or yj was selected to the LCS. Yes, no? If these two are equal, it means they are going to one out of them, because they are both of them are same. So this or this is going to be there in the final longest common subsequence. Fine. So this is the case number 1. So whenever this is the case, we need to put a diagonal arrow. Whenever this condition is activated, then we need to put a diagonal arrow in the same block. Same block कौन सी वाला, which was equal to C of ij. So we need to put a diagonal arrow in C of ij. Done. Why diagonal arrow? Because the next part in this equation means while calculating LCS, we need to add 1 and we need to move to the LCS of I minus 1 and j minus 1. And we already know that if this is a matrix, done, and if we need to move diagonally, then if we are at this position, then the next diagonal, this one, is going to be achieved. If this is I and j, then this is the next one is going to be equal to I minus 1 and j minus 1. So this is the reason that we put a diagonal arrow in this. Now move to the second one, second condition, that when xi was not equal to yj. So there were two options. One was to go for C of I minus 1 and j, and one was for going for C of I and j minus 1, and we need to choose the maximum out of these. Okay, so based upon this maximal condition, if this one is chosen, because we are representing I in terms of column and j in terms I in terms of rows and j in terms of columns. Done. So कहता है in that case, if this term is maximum, if this is maximum, it means we need to put a vertical arrow. Why vertical? कि कहता है कि मैं यदि यहाँ पर था, डन, मैं I और j पर यहाँ था, I and j. अब कहते हैं I और j के केस में xi was not equal to y of j. It means I need to consult the entry which was C of I minus 1 and j. अब कहते हैं C of I minus 1 and j कहाँ से निकलेगी? From here, just by decreasing the row number. So if this is ij, then this entry is going to be I minus 1 and j. Okay, so this is the logic behind putting a vertical arrow. And if this entry was going to be selected as maximum, then we need to move, or we need to put the horizontal arrow. Horizontal means if we are here, done, if we are here and the next entry that is to be consulted is equal to C of I and j minus 1. Okay, so for reaching from ij to c of I and j minus 1, we need to move horizontally. So if this is ij, then this is ij minus 1. Fine. So that is the logic behind putting the horizontal. Done. So these three arrows are going to make the things easier, to make the things working for printing the elements that constitute our longest common subsequences. Okay, now consider the solution for a problem when x was equal to a, b, c, b, d, a, b, and y was equal to b, d, c, a, b, and a. Okay, so this is the algorithm according to which we need to generate the matrix C. So this is our matrix C. So there are two parts for each and every block within the matrix. One is the value and second one is the arrow. So value, arrow, value, arrow, value, and arrow. So each block is containing value and an arrow. Fine. Arrows, I have already explained to you what exactly they mean. Fine. Diagonal means that there was a match, or wherever this is equal to 1 means I and jth entry for which there is a diagonal arrow, we means, and then we need to choose xi or yj to be belonging to our LCS. Done. If it was not equal, xyi was not equal to yj, then we need to choose maximum amongst I minus 1j and ij minus 1, and based upon their choice means either this is chosen or this is chosen. If this is chosen, then we need to put a vertical arrow. If this is chosen, then we need to put a horizontal arrow within this. Done. So this is the solution for this problem. Try to generate it by yourself. Very easy it is. Fine. Now we are at this entry which is equal to C of 7 and 6. So it gives 4 as the length of LCS. Length of LCS is equal to 4. So we got the length. Now we need to print the elements which constitute this LCS. So what is the process to generate that LCS? Process is very simple. Just consult the M and C of M and nth entry. Try to consult C of Mn. Observe the nature of arrow it is containing. If the arrow contained by C of M and N is diagonal, it means x of M, or you can say y of n were chosen. Print it. Okay, if this is the case, then the next block to be followed is C of M minus 1 and N minus 1. Okay, print kar dena hai. You need to print this one or this one, and you need to move to the diagonal element M minus 1 or N minus 1, or in terms of I of j, if we were on I and j, the arrow was diagonal, then we need to move to C of I minus 1 and j minus 1 after printing the value of xi or y of j. Okay, so by chance in this case the value is not diagonal, it means x7, or you can say x7 was not included. X7 is not there in the x7 is not there in your LCS, longest common subsequence. There is no x7. Fine. Now observe the entry contained by this C of 7 and 6. This is equal to vertical. It means move vertically. तो इसने क्या किया? It moved vertically and it reached to C of 6 and 6. Now observe the nature of arrow contained within 6 and 6. Now it is diagonal. If it is diagonal, it means x of 6 or y of 6 we can include. तो x of 6 क्या है, 6 है, y of 6 भी a है. This entry is equal to a and this is also equal to a. So choose either of them. It means the last part of the LCS is equal to a. Done. And there was diagonal arrow. It means we need to move to C of 5 and 5. Now move to C of 5 of 5. This one. Now this one contain vertical arrow. If this is vertical arrow, it means we need to move to which one? 4 and 5. Okay, now move to 4 and 5. This entry. Now C of 4y is containing diagonal arrow. It means we can choose x of 4 or y of 5. Okay, now look at x of 4 is equal to b and y of 5 is also equal to b. So next to be chosen is b. Next to be chosen is b. This is the result I am printing. Okay, now if this is the case, then we need to move to C of I minus 1 j minus 1. It means C of 3 and 4 we are going to move. So we made a move and reached here. Done. This entry. Now look at this entry. It is containing horizontal arrow. If it is horizontal arrow, it means it was not included. Done. If it was not included and horizontal arrow was there, then we need to consult entry 3 and 3 next. So it moved to 3 and 3. Done. Now C of 3 and 3 again contained the diagonal arrow. It means we can choose x of 3 or y of 3. Done. So x of 3 is C, y of 3 is again C. So we included it. And the next entry to be checked is C of 2 and 2. So we move to C of 2 and 2. This one. C of 2 and 2 is containing horizontal arrow. It means no need to include any symbol at this point. And next stage to move is 2 and 1. So we moved to 2 and 1. Done. This one. Now C of 2 1 is containing diagonal arrow. It means we can include x of 2 or y of 1. Done. Just observe x of 2 and y of 1, they are both b. So include it. Okay. So after including, we need to go to C of 1 and 0. Now we already know that C of 1 and 0 was equal to 0 or is the case when x1 was considered and nil was considered, nil portion of y was considered. So there is no use to going further. It means at this stage we'll be able to print this b we just left. So at this stage we'll be having our longest common subsequence printed. So the longest common subsequence is B, C, D and A. So this is how we are going to print the longest common subsequence. Now let us try to have a look at the algorithm for doing this thing. So this is the algorithm for printing your LCS. Now try to understand this. What exactly it says is that we are having the algorithm named print LCS. B, X and I and J was passed to it. Now what exactly is this B? This B is the matrix containing arrows. So while understanding this algorithm, this one LCS, I told you to leave it. Now it is time to understand this. So we initialize B to 1 to M and 1 to N. Done. And whenever this was equal, xi was equal to y of j, we put diagonal arrow. Done. If this was not the case, and if this is, or you can say if c of I minus 1 and j was greater than c of I and j minus 1, then we need to put vertical arrow in B of ij, else we need to put horizontal arrow within I and j. So this B matrix is going to become the basis for generation of or printing the LCS elements. Now try to understand this algorithm. So this is the algorithm, that is LCS. B is passed to it, X is passed to it, I is passed to it and J is passed to it. You can pass Y also here. Why? Why only one is needed? Because we are going to generate LCS from X and Y. LCS means common subsequence, means elements will be within X also, within Y also, so only one is required. Fine, you may take Y also. So what exactly it says is that initially this algorithm is going to be called using 7 B, X, 7 and 6 as arguments. Okay, so 7 and 6 as argument. So in this case, if I is equal to 0 or j is equal to 0, then we return, we need to stop, but this is false, because I is equal to 7 and j is equal to 6. It means we need to go here. Okay, now we need to check if b of ij was diagonal arrow. Here it was not diagonal. Okay, so it will not be executed. Done. It means we will be checking for the vertical arrow. Now vertical arrow is there. Vertical arrow is there. Okay, the vertical arrow, if this is vertical, then we need to call the algorithm recursively with arguments of I minus 1 and j. Means we need to move vertically, and for moving vertically we need to decrease the row number, and for moving horizontally we need to decrease the column number. Okay, yes, no, done. If we were there and there was vertical arrow, then we need to make a recursive call for printing x of 6 and y of 7. Fine, we need to print the strings, prints the values through this. Initially our target was to print x of 7 and y of 6, but we encountered vertical arrow at this entry 7 6. If vertical arrow is there, then we need to decrease the row number, or you can say we need to move upwards. Done. In the x6 and y6 we encountered a diagonal arrow. Done. If it is the diagonal arrow, it means we need to print it. Just consider this one. If it is equal to diagonal arrow, then we need to print this xi, and along with this we need to make a call to the algorithm with arguments which is in the form of decrease in the row number, decrease in the column number. Done. So this is the print algorithm for your longest common subsequences. Now try to give the time analysis for these algorithms. So this is the first one. The time complexity is very obvious, as we are going to generate a matrix of the order m is to n. Yes, no. So its complexity is going to be of the order of big O of m is to n. Now come to this part. The worst case complexity of this algorithm may be, in the worst case will be there when the B matrix is such that this contain vertical, this contain vertical, this contain vertical, and further this contain horizontal, this contain horizontal, this contain horizontal. So this may be the possible case. So if this is the case, then we are having m number of rows were there and n number of columns were there. So the complexity for the worst case of print algorithm is going to be m plus n. So this is the complexity analysis for your longest common subsequence problem. That's it.